All right. Oops. Today we're looking at center of mass. So let's start with the question, what is center of mass? Center of mass is where the entire weight of an object can be thought to center. Okay? In other words, it's concentrated mass is concentrated at that point, also known as center of gravity. Now, next time when I see you in class, we will be actually doing a little experiment with some coins to see if we can find the center of mass of an object. All right? Okay. So now, if we have a uniform rod, we know the rod, every molecule in the rod is attracted by the force of gravity. But instead of having to consider every individual molecule and center of gravity on each individual molecule, we can treat the entire thing as though it's acting at one place, and that would be its center of mass or center of gravity. And that would be typically the geometric center of that rod. Okay? So we have the entire rod all the way down. And like I said, instead of every individual place, instead what we're going to do is we're going to look at just the geographic center, which would be here. And we're going to talk about gravity acting down at that point, okay? So this would be my center of mass, or my center of gravity. Now that's only in the geographic center if the mass is uniform. In other words, it's evenly distributed. Then do you find the center of mass is at the geometric center of the body, okay? If the body is non-uniform, then the center of mass is at a point where a force equal to the weight of the mass can be balanced. That's why sometimes we call it center of gravity. It would be the balance point. So for its non-uniform, we're going to say it's the balance point. And this is what we'll be finding, because when we do our little lab, it's an easy little lab, but it's kind of interesting and fun. That's the point at which we will be actually finding the balance point, or that center of mass. So now how do we do this in one dimension? The formula for finding the center of mass in one dimension, the formula for finding the center of mass is going to be x center of mass is equal to, we're going to find the sum of all the x's times their masses. In other words, location times mass, and then we're going to divide that by the entire sum of their masses. All right, so for example, x center of mass would be equal to the mass of 1 times its location plus the mass of 2 times its location plus the mass of 3 times its location, etc. All divided by mass 1 plus mass 2 plus mass 3, and so on. All right, now in two dimensions, we're going to find it in the x direction. Sorry, I don't need the summation symbol there. We're going to find the x center of mass is going to be sum of the x's times their masses divided by the sum of the masses. And the y center of mass is, of course, going to be the sum of the y's times their masses divided by the sum of the mass. Okay? Now, for this particular coordinate plane we have right here, that would be x sub 1 times mass 1 plus x sub 2 times mass 2 divided by mass 1 plus mass 2. In other words, this times its x location, this times its location. And then thus, if we were to do this in terms of the y's, it would be y sub 1 mass 1 plus y sub 2 mass 2 times its location mass 1 plus mass 2. Okay? Easy enough to do. Now, let's look at a couple of examples here. And we will look at how do we calculate center of mass for different things. And I'm going to give you an additional example or two to go along with this. If we have a fireworks shell, and this is where it really comes into play here for center of mass, is if we have an explosion, because the center of mass, even though the two pieces are one particle explodes into many particles, the center of mass will continue along its initial trajectory. I bet you didn't know that. So if we have a fireworks shell reaching the top of a parabolic trajectory, in other words, it's flying like this, reaches the top and explodes, then what happens to the center mass of the experiment, or the shells? Even if you have one shell fragment go here and another shell fragment go here, flying off, the center of mass continues along that trajectory. So it will continue to move along the original parabolic trajectory. Okay? As long as there aren't any external forces. Now, if there are external forces, that's a whole different matter. But as long as there aren't any external forces, then it will continue as it was. Well, let's look at example B. 3 people stand around not doing their physics homework as shown below. Wonder where this example came from. Find the distance of the center of mass of the 3-person system from the leftmost person. So we're going to call the leftmost person this guy. We're going to call him at x equals 0. So now this guy's location is x is 4, and this guy's location is x is 10. All right, so now let's find their x center of mass. The x center of mass is going to be the location of the first guy times the mass of the first guy, location of the second guy times the mass of the second guy, location of the third guy times the mass of the third guy, divided by the sum of the masses. So let's see, location of the first guy is 0 times 70. This guy is 4, his location is 4, and he's 60. Next location is 10, and that's 82, divided by the sum total of their masses, which is 70 plus 60 plus 82. Now you notice that guy goes away. So it ends up being, could you guess where it's going to be? Add it up and divide, and you actually get 5 meters, but we have to be relative. This is from the left. So the center of mass, if we were to draw it in here, center of mass would be somewhere right around here, which kind of makes sense when you consider they're heavier. He's heavier on one side of him than he is on the other. Okay? So now, let's look at the fisherman question. Actually, before we look at the fisherman question, let's look at this. If I have a bar and a bar and another bar right here, okay? And I wanted to know, this is common sense, guys. And I want to know, I can pretty much tell you that the center mass is going to lie straight down the middle if all of those are the same mass, okay? So what I want to know is where down the middle does it lie? Does it lie here at A? Does it lie up here? Does it lie halfway in between? Halfway again? Or even partway between those? Where is the center of mass going to be? Could you give me an idea? All right, So let's talk about this one. We know it can't be at E because most of the weight is down here at the bottom, isn't it? So it's got to be somewhere in between there. And it's going to be closer to the bottom end than it is top end, isn't it? It's also not going to be halfway. Again, can it be halfway? Probably not, because it's all down at the bottom end. So it is going to cheat towards the bottom, isn't it? So it's not there. We know it's not going to be at A, because there's some mass up here too. There's some mass up here, there's some mass up there. So how do we figure out what this is going to be? How do we figure out where it's going to be? Now, I know it's straight down the middle because one side is the same as the other, so it's nicely done. So now, how can we figure it out? Let's say this is a distance L. This is L from here to here. And this is L from here to here. So what we can do is we can treat this as three separate, completely separate points, guys. So let's do that. I know the center of mass of this guy is going to be right in the middle. That first bar is going to be middle. Second bar is going to be in the middle. Third bar is going to be in the middle. And now I can figure out what those three locations are and treat it like they are 3 points instead of 3 bars. So now I just need to know the location. So the location of this guy is at 0, L over 2. The location of this guy is going to be at L over 2, 0. And the location of this guy is going to be at L over 2. And now I can actually find my center of mass in the x direction and the y direction. I know the x direction, what it is already. I mean, look at it. You've got L over 2, and 0. Easy enough. So let's talk about the y direction. So the y center of mass is going to be at what? First y coordinate is L over 2, and let's say they're all mass m. Second coordinate is going to be 0, L over 2. And the third coordinate is going to be L over 2 and mass m. Divided by, oops, this is, yeah. Oh, hang on a second. I think I just made a goof. Excuse me, this should be 0 times m. All right, so this one's going to go away, divided by 3m. So L over 2 divided by L over 2 is going to be L m over 3m. So it's going to be L over 3. So it's going to be about a third of the way up. Well, if you look at B is exactly halfway up the half. So this is L over 4. So my answer would be C at L over 3, a third of the way. It's a third of the way up, okay? So now let's look at this example C again. So here we go. Fisherman stands at the back of a perfectly symmetrical boat of length L. The boat is at rest in the middle of a perfectly still and peaceful lake. Just listen to the birds singing. It's wonderful. The fisherman has a mass 1/4 that of the boat. So if the mass of the boat is m, his mass is 1/4 m, or m over 4, okay? If the fisherman walks to the front of the boat, by how much is the boat displaced? Guys, you have to know that the center of mass of the boat is going to stay in the same place. Remember what we said about the trajectory, that in the beginning and the end, even if it explodes in mid-trajectory, the center of mass continues on in the same trajectory. Well, this is the same idea. The center of mass there's no external forces. The center of mass doesn't move. Now note I didn't say the boat didn't move. I said the center of mass doesn't move. So what we're talking about is that if in the beginning, he's standing here at the end, and the center of mass of this thing is, here's the boat, the center of mass would be slightly off of that, right? So it'd be right about there. Do you agree that when he moves forward, the boat is going to move backwards? So as he walks forward, the boat's moving backwards underneath him. Well, what we find out then, though, is that this center of mass stays in the same place even when the boat itself moves. So we're going to figure out where that is. So now we know the center of mass has moved to the other side, which only makes sense if you consider that now he's standing on the other side of the boat. But the center of mass itself did not change positions. Only the boat moved out from underneath it, if that makes sense. Just think about it. That's why the boat moves when he moves, is to keep that center of mass in the same place. Otherwise, it would tip over. Think about it. So how can we figure out where that is? Okay. Let's find out. So what do we know? Center of mass in the x direction. Let's call him at 0. So we've got to first thing we've got to do is put in a coordinate system. So he's at 0, this is L. Okay? So his initial position is at 0, and this position is at L over 2 because its center of mass is at the middle of the boat. So we have a location of 0, m over 4, plus let's do this the right way. His position, which is L over 2, the boat's position, which is L over 2 times m, all over total mass, which is m, and m over 4. So this goes away. We have Lm over 2 divided by 5/4 m, so the m goes away, and we end up with 4L over 10, because this flips over and becomes 4 over 5, doesn't it? Which reduces to 2/5 L. So the center of mass is now at 2/5 L. Okay? So the center of mass afterwards is what? Oh, in the beginning. The center of mass in the beginning is at 2/5. So now we need to figure out where it is, where it ends up. So where does it end up? The center of mass afterwards. He is now down at L, isn't he? And this is still at L over 2. So let's do this again. We have a location of L, m over 4. Location at L over 2, m. And then we have 5/4 m at the bottom. Still total mass, don't we? So we get rid of our m's. And we have L over 4 plus L over 2, which is 3L over 4. And 5 over 4. So 3L over 4 times 4 over 5. We're now at 3L over 5. So now this guy is at 3L over 5. So if it moved from 2L over 5 to 3L over 5, how much did it move? Well, how far is that? So let's go in a different color so you can really see this. It's effectively what we're saying is it started at 2/5 L and ended up at 3/5 L. Well, how far is that? Well, we just have to subtract, don't we? It was displaced 3L over 5 minus 2L over 5, which is just L over 5. He displaced L over 5. That's how much it moved. It moved 1/5 of its total length towards the fisherman, right? Out from underneath the fisherman. All right. So It's a short lesson, but it's an important one as we go forward because center of mass is an important idea. We'll reinforce this next time with a lab, and then we will be moving into reviewing momentum.